Good afternoon, everyone. Happy Monday. I do have an announcement to make. I'm going to push your test a couple of days later. So let me announce that as our first announcement for today being Monday, April 19th, 2021. I've decided to move your exam to next Wednesday, which is officially the last day of class. So test 4 is going to be next Wednesday. It's the same format as test 1, test 2, and test 3. But this time, instead of next Monday, it's going to be next Wednesday, the 28th. And this is the last day of class. Okay, the very last day of class. And having said that, the way my system works is the quiz is going to be due on the same day as the test. So quiz 4 will be due next Wednesday. Okay, if you don't want to take the quiz because you are happy with your scores from quiz 1, quiz 2, or quiz 3, that's totally fine. You don't turn in the quiz. Okay, but if you think you can score high enough and want the top three quizzes scored, you can turn in quiz 4. So that's the major announcement, and I'll post this on Canvas as well. Your test will cover chapter 17 and 18, and I made a study guide for that on Canvas. So if you want a heads up on what you will see next Wednesday, you can check out Canvas. There's a problem set and a multiple choice set like all the other exams. Okay, so problem set and multiple choice set. All right, the next announcement has to do with lab reports. So there's 2 lab reports that need to be turned in for points. One is the problem set. The problem set, and the other one is spontaneity, which is actually due this Friday. So there's no lab this Friday. I thought I'd do an extra credit lab, but I figure let people catch up on their lab reports and catch up on their chemistry too. So there's nothing this Friday. So, but what is due this Friday is the lab report on spontaneity, and that's due this Friday. So make sure you turn that in. And now is the time I will tell you when your lab notebook is due. I'm going to collect that next Monday, okay, for 100 points. I hope you've been keeping up with your lab notebook. Maybe 1 or 2 students have come to labs that have been doing that. So lab notebook is going to be due on Monday, which is 4/26. Okay, so Josh, I changed the test from next Monday to next Wednesday. Right. Next Wednesday is the final day of class. I'll still have class Wednesday if you want to come, but hopefully I'll be all done. If I'm not done, whatever I missed, I'll cover it on Wednesday. Then you can take your exam. All right, exam just as before. Multiple choice and a problem set. All right, so make sure you upload the problem set, show your work, and do your multiple choice of that test. Turn in your lab notebook next Monday. I'll give you 100 points. Lab reports. And also homework 18. I have some videos concerning homework 18 that you can use to watch along. And let's make that due next Monday as well as we wrap up the semester. Okay, so these homeworks, like I said before, are practice, and I just give you 10 points and should help you understand, get a better knowledge of the material on hand. So do the homeworks. If you have any issues, you can watch the videos I posted for each of the homeworks. You can also look at the solution manual that's on Canvas. And anything else? Those of you that are outside of this is outside the realm of this class, but if you're doing the clutch prep stuff, continue to do that for chapter 18 And when everything... I'm sorry? Yeah, I'll talk about that. Clutch prep. So continue to do that, and when everything is done with the semester, I'll take a look and see who did everything, and I'll add a couple of percentage points. Not a lot, but whatever little I'll add, I will add. Okay, clutch prep, drills. All right, and finally, as Adriana reminded me, this is a final exam that's not optional, though I want you to take it. It's cumulative. And that's May 3rd, 11 a.m., right? Yeah. 11 a.m., okay. So this is going to be about 25 to 30 multiple choice questions, and it's just basically an evaluation. All right, so are you guys learning more about pH? Do you guys know about reaction rates? Are you guys struggling with voltage? All right, so that's what this exam is about. It's not going to harm you. It's just more an assessment for me as the instructor. If you do score well in it, I will replace a low test. But if you don't score well in it, you don't have to worry about it. I won't do anything. I'll just discard it. Okay. Do take the exam, but don't guess. Like, don't click A, B, C, D, D. Just test yourself, and we use that information to see, should we focus more on this, focus less on that? What are you guys learning? What can I do better in my job in terms of teaching? So that's what the final exam is about, and do take that, I think, for May 3rd, Adriana said, and 11 a.m. That's dictated by the school, by the way, not me. Okay, the school has told us Monday, Wednesday, Friday, 1 o'clock is the exam. Any other questions or comments?
It's just through Canvas.
This will be through Canvas, yeah.
And it needs to be taken at 11?
I think I'm going to put it at 11, yeah. Put it at 11. I'll give you like 2 or 3 hours. Yeah. Probably 2 hours. Okay. So take it, definitely. Take it with the intent to do good. Don't take it because I'm forcing you. Bless you. See, okay? That's the truth. In my culture, like when you say something, this is my culture. I grew in India. You say something and somebody sneezes, like Robert did, that's supposed to mean truth. So whatever I said.
You just said that. You just said about our exam. Take it with good intent.
And then he sneezed, and that means I'm trying to tell you the truth. I mean, I don't know if it's a superstition or not, but when somebody says something and then right afterwards somebody sneezes, that means whatever that other guy said is truth or is profound or something.
I confirmed it.
The sneeze confirmed it, if you believe in that stuff. Kind of like other things. Have you heard of knock on wood? That's kind of like that.
What's for somebody that's lying?
Somebody that's what?
What's for somebody that's lying? Is there a tell for somebody?
Lying. No, lying. Body language. I don't know. Scratching their nose. Here's another example. Break a leg. Yeah. You really going to go break a leg? Break a leg means good luck. In my culture, if you sneeze after somebody says something, that statement is usually true. So, all right. That's your lecture for today that's not related to chemistry. All right, let's finish this up here. So anything else that I'm missing? All right, so next Wednesday is the day, and we just have to finish this chapter notes, and then we'll have a review, and that's it. All right, let me just tell you a couple of important points here. So make sure you have this available for your exam. Okay, I got extra copies, and I think it's also on Canvas for you to print out or have it open on another computer screen tab. First of all, this is standard state. Okay, standard state, 25 degrees, all the way down at the bottom here. Standard state, 1 molar. Everyone see that bottom footnote? and 1 atmosphere for gases. So all these voltages are at standard state. Okay, number 1, important point number 1. Important point number 2, a lot of people miss this, unfortunately, and I'm trying to figure out how to better explain it. All of these are reduction reactions. You see this gains 2 electrons. O3 plus H plus 2E minus gains 2 electrons. Here, cobalt plus 3 gains 1 electron, so on and so forth, all the way down the page. And if it gains an electron, we call that a reduction half reaction. So all of these are reductions. You can just look at the title here, reduction. So all of these are reduction half reactions. Okay, that's important point number 1. Okay, important point number 2, this is standard state. Which means the E has a little superscript naught, which means the E has a superscript O, which is also called naught. E naught, delta G naught, S naught, okay, delta H naught, all those quote-unquote knots, it means standard state. Again, 25 degrees C and all these different conditions. Okay. All of these are reduction half reactions. Okay. The next important point I want to tell you, let's just put it here on this white sheet. I'll use this as an example. I'm going to just rewrite this. F2 gas plus 2E minus goes to 2F minus. And that has a voltage associated with it of plus 2.87 volts. Positive 2.87 volts. Okay, so do you think looking at just this half reaction, realizing, a full reaction is a half reaction with another half reaction, but look at this positive sign here. Is that something that's is the positive value something that's positive? Yes, meaning it's going to move forward. Okay, positive. So this is something that's favored. Let's say it's favored. So it's going to be favored, favoring the products. Why am I saying favored here? Because of the positive value. Usually a positive voltage has some voltage. If it's negative voltage, we consider that a dead battery. Speaking of battery, a battery has 2 parts. One is the cathode and the other is the anode. And this would be the cathode. Red cat eats an ox. So this would be not only a reduction reaction, but also a cathode. All right, so that's one important point. Now the next thing I'm going to do is I'm going to flip it. Okay. How about I don't flip this? I flip something else. Let's flip something else. Let's flip this. Just anything off the top of our head, off the top of our sheet here. I'm going to flip. AU means gold. I'm going to flip that. So instead of writing it this way, I'm going to write it in the reverse. So follow along with me. AU solid is going to go to AU plus 3 and 3 electrons. So AU solid. AU plus 3. Okay, so I'm taking another reaction, this one here with my blue arrow, with the blue arrow. Because I flipped it, this is the important point, you flip the sign. So instead of positive 1.50 volts, what will it be? Negative. Okay, is this negative 1.50 volts favored or disfavored? negative. Yeah, we don't think of negative voltage, so that's disfavored. It does not favor the products. You agree it favors the reactants. So this will probably be a no-go half reaction. So this is disfavored. Okay. And this is a half reaction, but I'm going to call it the anode. Okay, anode. Here I'd like to ask you to memorize Leo Gur. Lose electrons, oxidation. So you see here, this lost 3 electrons. I'm going to box it here. It lost 3 electrons in the product side. This cathode here, gain electrons reduction. I'm going to circle it here. This F2 gained 2 electrons here. Okay, so we have a battery now. Okay, cathode. I flipped this one here, making it the anode. I flipped this one here, making it the anode. And let's add them up, realizing a battery is a cathode and an anode put together. No free electrons. Okay, get rid of those electrons. So how do you think I'll get rid of those electrons? Well, I'm going to multiply this top one by 3. And I will multiply this bottom half reaction by 2. Everyone see that? Okay, so this is what you'll have to do on an exam or on your homeworks. So let's rewrite this now. 3F2 gas plus 6E minus goes to 6F minus aqueous. All right, 3 times 2.87, do we do that? Okay, remember on Friday's lecture? Okay, no, this stays the same. Okay, this stays the same. It's still positive 2.87 volts. Okay, this is huge, okay? Very important point. Stays the same. Let's put some red stars by it. A lot of students will multiply this out by 3. Okay, for this thing, no. Okay, so it stays the same. The voltage stays the same. All right, what about the bottom half reaction? It's going to be 2AU. It goes to 2AU plus 3 plus 6E minus 6 electrons. Is this 2 times minus 1.50 volts? No. Okay, it still stays the same. It's still minus 1.50 volts. Okay, let's put a big asterisk sign here. Voltage stays the same. Okay, this is something people can easily slip up on. Just because you multiplied by 3, people think, oh, I have to multiply this number also by 3. No, don't do that. Voltage stays the same. All right, so you always want to cancel out your electrons. 6E minus in this reactant side cancels the 6E minus on the product side. Remember, free electrons are bad. Okay, they really are bad for you. And now we add the 2 reactions. We add the cathode, we add the anode. So here we have 3F2 gas plus 2AU solid is going to go to 2AU plus 3 plus 6F minus 2.87 minus 1.50. We have to add these 2 up together. I should do this in my head, but 2.87 plus a minus 1.50, it's 1.37 volts. Okay, this is a very good battery in the sense that it's positive, and you get about 1.3 volts in that battery, consisting of fluorine gas and Au solid. So, yeah. And this would be the equation giving off 1.37 volts. Is this favored or disfavored? It's positive. Positive E cell is favored. Okay? You cannot have a negative voltage for a battery. Okay, all the batteries, okay, the batteries in this remote control, they don't run on negative volts. They run on positive voltage. This reaction gives off 1.37 volts, so yes, it's a good battery. And, this reaction is favored.
I did something wrong.
Sorry.
No, it's okay.
How do I get it off? Clear?
Exit.
Exit, clear. Yeah.
It's gone now, so
So the reaction is favored. Positive voltage. If this was negative voltage, what would you say?
it's not there.
Not favored. Very good. If it's negative voltage, you put not favored. This reaction is no-go if it's negative. Because this is positive, it's favored. Thumbs up. Okay. Right, another thing that I talked over on Friday, there's another way to write this. You can write this as anode couple. You're going to put two lines, which represents a salt bridge, and then follow that by the cathode couple. All right, so what is our anode couple? Our anode couple, everyone see, is Au going to Au plus 3, right? Let's write that here. Au solid, you put one line, Au plus 3. Okay, that's our anode couple. Let's put our salt bridge. These two lines represent a salt bridge. And then we follow that up with a cathode couple. What is our cathode? Gain electrons, reduction. Reduction occurs at the cathode. F2 going to 2F minus. Okay. So F2 going to 2F minus represents your cathode couple. So it's F2 gas. Here we put one line, and I guess you can put 2F minus aqueous. You can also remove the 2. It doesn't matter if you put the 2 in or not. But
So you don't need constants?
yeah, I've seen it both ways. You don't need the constants. But if you put the 2 in, that's fine. It's not like not like the end of the world. All right. So, what is the world, or I guess, what is important, I should say, is putting the 2 or not is not the end all be all. But to go from here to here or from there to there, that's what I want you guys to be comfortable with. Okay, so if I give you this on the exam, can you go ahead and do this? Okay, anode couple, salt bridge, cathode couple. If I give you this all alone on the exam, can you go and give you that, generate this balanced redox reaction? See, these two inside the pink boxes are the same. They are the same. They mean the same and they imply the same thing. Okay, that's the important thing. So be comfortable going back and forth between the two. So let me teach you how to read this thing here. For that, let's get another one here. Right, so how do we read this thing here? First of all of these are voltages, okay? And, you know, if we want to make a battery, we need a cathode and an anode. And we want a positive voltage, right? Positive voltage is what gives us a battery. No matter how crude or how low the voltage is, positive voltage is what we need. Okay, but you see how these are all, you see how all of these have an order? Okay, first it's F2, then it's O3, then it's CO plus 3. And then it's H2O2, then blah, 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 all the way down, okay? So this is how it works. Let's see, how can I explain this? You see F2 is at the top, right? Okay, whatever is at the top can flip anything below it. So F2 is at the top. It's at the topmost. I'm going to pick Ag solid here. Ag is silver. F2 can flip F2 can flip Ag solid, flip. Let's do a flip sound, flip it so that Ag solid gets oxidized to Ag plus. Gets oxidized to Ag plus. Gets oxidized to Ag plus. It flips it. So whatever is on the top can flip whatever is beneath it to get a positive voltage. Whatever is on the top can flip it, the bottom, whatever is beneath it, and you'll still get a positive voltage. Remember the preface? I started this by saying you need a positive voltage to get a battery. So F2 plus 2E minus to 2F goes to 2F minus is positive 2.87. If you flip this, Ag solid gets flipped to Ag plus E minus. You flip the sign, right? Right? Let me just... What's 2.87 minus 0.80? Positive or negative? It's still positive. So you see F2 can cause the oxidation of Ag solid to Ag plus. F2 can cause the oxidation F2 can cause the oxidation of Ag solid to Ag plus. It can, you'll get a positive voltage. So this is kind of what we call the diagonal rule, all right? So anything below it can get flipped by anything above it. So this is kind of hard to envision, but it's the diagonal, okay? So can F2 oxidize Ag solid to Ag plus? Yes. Can F2 oxidize CO plus 2 to CO plus 3? Yes. Can F2 oxidize Ce plus 3 to Ce plus 4? Flip it? Yes. Okay. How about O2? Can O2 oxidize I minus to I2 solid? Yes or no? Yes. Okay, because O2 is here, I minus is below it, it can cause anything beneath it to flip to get a positive value. Okay.
Now what if it's on the, it doesn't matter what side it's on? Or
It does matter, because O2 will cause, I'll pick on copper here since it's beneath it. O2 will cause copper solid to flip and get converted to Cu plus 2. That will give us a positive voltage, because 1.23 minus 0.34 is still positive.
So it doesn't work the other way, or
It doesn't work the other way. I see what you're trying to say,
Yeah, I'm just
Adrian.
making sure.
Yeah, so O2 will cause Cu copper solid to get oxidized.
Right.
Copper solid cannot cause O2 to get oxidized, can it? It cannot flip. If you flip this, 0.34 minus 1.23 is still negative. So it cannot flip.
But I'm saying like the other side of the reaction. It doesn't work that way. Like,
No,
if
because
you
this
took
is,
it wouldn't work, right?
yeah, O2,
Yeah, no, like if you took like from the O2 one that's up top, if you took 2H2O and did it like on
Above
the
it?
She
product,
means like products.
Yeah,
Instead of
anything
taking
the product.
reactants
Okay.
down.
can you go from product to reactant or just reactant to product? That's fine.
give me an example.
Like the 2H2O from the
2H2O, where is that?
right.
On your
On the
O2
product,
with
yeah.
this square in it.
Okay.
Yeah, like can you take that and flip another reaction?
This cannot flip. This is a, no, this cannot flip.
So the product can't do it.
Yeah, this is going to be 1.23, and flip. Let me change. Okay.
I just don't want to have a question about it.
I think if you want to say it that way, you can, because yeah, this can flip anything below it
Okay.
and stay the same.
Okay.
Yeah, this can flip anything below it.
Okay.
Now, can this flip anything above it?
No.
You'll get a negative voltage.
Right.
Okay, so this cannot oxidize this. Okay, this cannot oxidize Cr2O7. This, I'm looking at the O2 here. This O2 cannot oxidize Au plus 3. It cannot. Why? Because if you oxidize Au plus 3, you get minus 1.54, minus 1.51, excuse me. 1.23 minus 1.51 is negative. Can't have negative voltage. So yeah, the answer to your question is yeah. If you want to look at it, the products. Look at it this way, Adriana. Any reaction can cause anything below it to flip and give you positive voltage, which is what we want. By the way, if the reaction flips everything below it, when it flips everything below it, it becomes the anode, and this reaction you're looking at still remains the cathode. Is that something that's clear or confusing? Let's go down here where there's some white space. How about cadmium here? Just put a box around it. All right. So here's some true or false questions for you guys. Cadmium plus 2 gains 2 electrons, becomes cadmium solid. That's minus 0.40 volts. Is that favored or disfavored? Disfavored, because negative voltage is usually not good. All right, can this cadmium plus 2 oxidize nickel solid, cause that to flip to nickel plus 2? Okay, the answer here is no. So that's going to be a negative voltage. Okay. But can this cadmium plus 2 oxidize zinc solid to zinc plus 2? Yes. Okay. That will give you a positive voltage. So cadmium can flip all these guys beneath it. That's all I'm trying to say. All right, let me tell it to you in another way to try to confuse you, because everything is about confusion. All right, cadmium can oxidize zinc solid to zinc plus 2. All right. Can zinc solid reduce? Okay, look at my wording here. Can zinc solid reduce cadmium plus 2 to cadmium solid? Yes or no? Reduce. Okay, can zinc solid reduce cadmium plus 2 to cadmium solid? Yes or no? Reduce. Okay, the answer is yes. Zinc solid can reduce cadmium plus 2 to cadmium solid, just as cadmium plus 2 can oxidize zinc solid to zinc plus 2. Okay, that's kind of tricky. Let me repeat it again. Cadmium solid can oxidize zinc solid to zinc plus 2. Along the same vein, zinc solid can reduce now, cadmium plus 2 to cadmium solid. All right. So that's the so-called diagonal rule. Okay. All right, let's look at this one here. Can magnesium reduce aluminum to aluminum solid? Yes or no? Can magnesium reduce?
Yes.
Yes. Okay. Magnesium can reduce Al plus 3 to Al solid. By the way, if magnesium it reduces Al plus 3 to Al solid, it becomes Mg plus 2. Can aluminum plus 3 oxidize magnesium solid to magnesium plus 2? Yes. Yes.
Okay. Before you were reducing positive voltages of lesser value. Now you're doing with negative voltages to other negative voltages.
Yeah. Because look here. That's a good point. Al plus 3 goes to plus 3 electrons goes to Al solid. How many voltages is that? You agree, Robert? It's minus 1.18. All right. And I'm saying that it flips everything below it. So if it flips magnesium solid to magnesium plus 2, we flip this. What do we do with the sign? Flip it. So what's minus 1.18 plus 2.37? Remember, I flipped this. Why did I flip this?
Because you're reversing the reaction.
Correct. So minus 1.18 plus 2.37, is that positive or negative? It's positive.
But I'm saying, can you do that with a voltage that's initially positive to one that's negative?
Yeah, you can do it as long as you get a positive answer. Whatever you flip, and that converts it to positive. And you keep the one above it the same value. If it's still positive, then it's positive. It's a positive voltage.
Okay.
I mean, yeah. Let me give you another example here. Barium, and we're getting at the bottom of the list. Barium, okay. Negative 2.90 volts. What can barium oxidize? There's only 2 elements barium can oxidize. What are those? K plus, and what's the other one? Lithium. So barium plus 2 can only oxidize K solid, and Li solid. In doing so, minus 2.89 flips this positive 2.90, still positive. Minus 2.89 flips minus 2.90 flips this, makes it still positive. Minus 2.90 flips this, it's still positive when you add them together. Okay. It's tricky. All right, how about this here? Can copper reduce iodine, solid? Yes. Yes. Okay. Can copper, this same copper, reduce Pb plus 2?
No, it would oxidize.
It would oxidize it perfectly. So when I say oxidize it, it would flip it. Okay, does that make sense? That's how you read this thing. All right. So I'll give you a bunch of true-false questions on the exam. Okay, this is how you're going to want to do it. Can sulfate reduce Sn plus 4? No. Okay, can sulfate oxidize Sn plus 2 to Sn plus 4? Yes. Yes, it can. Yes, it can. Okay, so that's what you're doing when you're looking at the diagonal rule. Okay. You pick one, just pick one, any one. It doesn't have to be at the top, middle, bottom. It flips everything beneath it. It flips everything beneath it so that it becomes positive. That's how you're going to do it. By the way, if you flip it, it becomes the anode. If you leave it as is, it becomes the cathode. This definitely takes some practice, so we'll do this in Wednesday's class and then Friday's class. But for now, let's just move on to the next part here. The last 5 minutes or so. By the way, there's one term I want to teach you guys. Go back here. Let's go all the way to the bottom. I'll highlight this in orange. At the very bottom, lithium plus E minus, 1 electron, to lithium solid, negative 3.05 volts. Here, the very bottom is what we call the best reducing agent. So this is confusing, okay? This is the best reducing agent. So the reducing agent is the agent that becomes oxidized. Okay. It's very good at becoming oxidized. Very, very bottom. We'll go to the very top later. So minus 3.05, is that favored or disfavored? Negative. Disfavored. Okay, what about the reverse? At positive 3.05 volts, it's very favored. It's the highest value here if you flip it. So you see, flipping it and making it oxidation, losing 1 electron, is very favored. So we say lithium is a good reducing agent because it's very good at getting oxidized. You see, if we flip it, it's positive 3.05 volts. Remember, there has to be a couple here. Let's go back to Elena and I. Let's say I am the reducing agent. Okay, I'm very good at getting oxidized and causing your reduction. I'm a very good agent in getting you reduced. In turn, I'm very good at oxidizing myself. So that's a reducing agent. Okay, I am very good at getting you reduced. And when I get you reduced, I'm becoming oxidized. I'm very good at that. And lithium is the very best. Okay, let's go all the way to the top. Okay, let's highlight this top one pink. Okay, we're going to call fluorine, F2 gas, the best oxidizing agent. Okay. That's this top part here, F2 gas. And an oxidizing agent is an agent that's very good at getting reduced. Okay, agent very good at getting reduced. All right, so let's see here, you guys. F2 gas plus 2E minus goes to 2F minus. Positive 2.87, is that favored or disfavored? Positive 2.87? Very favored. In fact, that's the most positive value you see in this whole table. Okay, so it's very good at getting reduced, in turn causing someone else's oxidation. Okay, so that is an oxidizing agent. So let's say, back to the example of the redox couple between Elena and I, if I am a good oxidizing agent, I'm very good at getting you oxidized. I'm very good at getting you oxidized. In turn, I myself am very good at reducing myself. You see, I'm an oxidizing agent. I'm very good at getting you oxidized. I'm going to cause your oxidation. Very good at that. In turn, I'm going to reduce myself. I'm very good at getting reduced, and I'm very good as an agent, the oxidizing agent, in causing your oxidation, because all of this is a couple. Okay, all of this is a partnership. And as an oxidizing agent, I'm the agent that's going to cause your oxidation, in turn causing my reduction. On the flip side, if I'm a very good reducing agent, I'm the agent that's going to cause your reduction, and in turn, I become oxidized. All right, let's end class today, and I'll see you all on Wednesday. Okay, so don't forget to keep up and keep pace with your work, quiz, homeworks, lab reports, so on and so forth. And I changed the test date next Wednesday.